Good morning, class. I hope everyone is doing well. We have already started a chapter number 6, heat and energy, in our last class, and we have already discussed about heat and temperature, right? So today we are going to discuss about a topic called thermal expansion. Thermal expansion. Okay, so you know the meaning of word expansion means to expand, isn't it? Yes, borno, fully no, right? Now this expansion is taking place because of thermal means heat. Are you getting my point? Yes, so this is what we are going to learn today. So now whenever you are attending my class, I would like you all to take your book, because I asked you to underline, take a note, put a star mark on so many things, isn't it? So please get ready. You can right now, if you don't have your book near to you, you can pause the video, get the book and pencil, and then play the video again. Okay, so we are now going to discuss thermal expansion. Now what is thermal expansion? Let's understand. Almost all substances, solids, liquid and gas, expand on heating and contract on cooling. So the expansion of a substance on heating is called thermal expansion of that substance. So that is your definition. Okay, definition of thermal expansion of a substance on heating. So whenever you are heating a substance, it will expand. Now a solid has a definite shape. So when solid has a definite shape. So when a solid is heated, it expands in all direction. That is through the length. Please underline this words here: length, area, and volume. All increase on heating. The increase on the length is called linear expansion. The increase in area is called the superficial expansion. Please underline all these things, all these lines. And the increase in volume is called a cubical expansion. Okay, all right. So solids may expand. Solids can expand in three ways. That is through lengthwise, through breadthwise, understand? Or you can say, in place of breadth, you can write area, in the lengthwise, area wise, and the volume wise. So solids, when you are heating, the solids may expand in lengthwise, area wise, or volume wise. Lengthwise is called as linear expansion. What do you call it? Linear expansion. And the area wise is called as superficial expansion. All right, and the volume was is called as cubical expansion. So expansion in solids, when you are heating the solids may expand in three ways. In the lengthwise, that is called linear expansion. In the area wise, that is superficial expansion. In the volume wise, that is cubical expansion. So I may ask you in the exams, what do you mean by linear expansion? In solids. So linear expansion is when the solid is heated, if the length of the solid increases, then we call it as linear expansion. Now when heating the solid, if the area of the solid increases, we call it as superficial expansion. And if the volume of the solid increases on heating, we call it as cubical expansion. So what do we call it? Cubical expansion. So now again, let's go to the page. Here the liquids have and gases do not have a definite shape, so they have only the cubical expansion. Very important. Please underline and put a star on it. On heating, liquid expands more than solids and gases expands much more than liquids. So please try to understand here. Now since liquids and gas, they do not have a definite shape, but they have definite liquids have definite volume. Understand? So that is why when you are heating solids and gas, they will show only the expansion in the volume wise. Only in the volume wise, that is cubical expansion. Liquids or gas ma chahi when you are heating liquids and gases, what kind of expansion is seen? Only in the volume, that is cubical expansion. Whereas in solids, all three kinds of expansion can be seen, that is through the length, that is linear expansion, that is through area, superficial expansion, and the third one is volume, that is cubical expansion. Now if you have to compare between solid, liquid and gas, and when you are heating them, when you are heating this solid, liquid and gas, which one expands the most? कुन चाहिँ त सबभन्दा बेसी expand हुन्छ is gas. Gases expands the most on heating. Whereas if you compare solid and liquid, liquid expands much more as compared to solid, and solid expands the least if you compare all the three states of matter, that is solid, liquid and gas. Alright, so I hope you understood this. Yes. Okay, now let's go to the next next paragraph. It says some substance such as water from 0 degree to 4 degree, silver iodide, please underline this, from 80 degree to 141 degree Celsius, silica below minus 80 degree Celsius contract on heating and expand on cooling. So here, see, what we are trying to see here is you have understood that whenever you are heating some substance, it expands. Heat गर्दाखेरि जहिले पनि what will happen? It will expand the substance. Whether it is solid, liquid and gas, they will expand. But there are certain substances like water from 0 degree to 4 degree, 0 degree to 4 degrees Celsius. Understand? This is our water. Then I have silver iodide from 80 degree to 141 degree Celsius. Understand? Similarly, silica at minus 80 degree Celsius. When you are heating them at this temperature range, what will happen? When you are heating them, they will contract. Expand हुँदैन. The opposite of expand is contract. बढ्दैन, के हुन्छ? घट्दैन. Such kind of expansion on heating, such kind of expansion on cooling, understand, is called anomalous. Anomalous expansion. So here, see, when you are heating a substance, it's expand. When you are cooling a substance, it's contract. It's contract, isn't it? But here you see that these are the substances, when you are heating them, they contract, and when you cool them, they expand. So this behavior of these substances are called as anomalous expansion, and that is our next topic here in our book, anomalous expansion of water. So we are taking water. Now if we take some water at 0 degree Celsius and start heating it, we find that it contracts instead of expanding in the temperature range from 0 degree to 4 degree Celsius. You must remember, from 0 degree Celsius to 4 degree Celsius it will contract on heating. On heating it further above 4 degrees Celsius, it expands. Similarly, if water initially at temperature above 4 degrees Celsius is cooled, it contracts till the temperature or water reaches 4 degrees Celsius. On further cooling it below 4 degrees Celsius to 0, it expands. This unusual expansion of water on cooling in the temperature range from 4 degrees Celsius to 0 degrees Celsius is called anomalous expansion of water. So this is the definition here, or the explanation. The expansion of water when it is cooled from 4 degrees Celsius to 0 degrees Celsius is known as anomalous expansion of water. So you can put a star mark on this. So when I ask you what do you mean by the anomalous expansion of water, you will say the expansion of water when it is cooled from 4 degrees Celsius to 0 degrees Celsius. It is called anomalous expansion. Alright? Yes? So that's all you need to remember from this. Okay? You do not forget that it is the expansion of water when you are cooling it. Okay? When you are cooling it. So you have a figure number 6.1 on your book. Okay, this is the figure. Here you see that figure number 6.1 shows the variation in volume of 1 gram of water. So when you are taking 1 gram of water, okay, 1 gram of water, okay, and in the range of 0 degree to 10 degrees Celsius, the volume of water first decreases on heating from 0 degrees Celsius to 4 degrees Celsius and then increases on further heating it from 4 degrees Celsius to 10 degree Celsius. So the volume of water is thus minimum at 4 degrees Celsius. So please remember, the volume of water is minimum at 4 degrees Celsius. Understand? Are you getting my point? So now figure number 6.2, this figure, okay, shows the variation in density of water with temperature range from 0 degrees Celsius to 10 degree Celsius. So initially it is seen, first it is increases, okay, then it decreases. Are you getting my point? First it increases, then it decreases. So from this experiment you see that the density of water is maximum at 4 degree Celsius. So what I am trying to say here, you don't have to remember all those things. You just have to remember one thing, that is water, okay, has maximum density. Please remember, maximum density of water is at 4 degree Celsius. Put a star mark here and learn this by heart, that at 4 degrees Celsius water has maximum density. Okay, now let's see the experiment which is called as Hope's experiment. Okay, here you have on your book, you can follow it. In 1805, please follow on your book, the scientist, okay, so what you do is you just hear my audio, hear my voice and follow the book. Okay, we are discussing now topic number 6.5, Hope's experiment. Now what is this experiment? To show or to demonstrate the anomalous expansion of water, that is water expands on cooling from 4 degrees Celsius to 0 degree Celsius. Alright, so now please follow it. In 1805, the scientist T.C. Hope devised a simple arrangement known as Hope's apparatus for demonstrating the anomalous expansion of water. Figure number 6.3 shows the Hope's apparatus. The apparatus consists of a tall metallic cylinder provided with two side openings P near the top and Q near the bottom, fitted with thermometers T1 and T2 respectively. So you can see the figure. The central part of the cylinder is surrounded by a cylindrical trough, trays are there, okay, containing a freezing mixture of ice and salt. So what do you mean by freezing mixture? Freezing mixture is the mixture of ice and salt, common salt, the salt that we use to cook our food, okay. The cylinder is filled with pure water at room temperature. The temperature recorded by both the thermometers is observed at a regular interval of time. So you can see this figure number 6.3 on your book. This is Hope's apparatus. It has a metallic cylinder where there are two holes on the top and the bottom. Through the two holes, what do you place? Two thermometers T1 and T2. At the center of the cylinder you have a trough. There are trays. The tray much you put a freezing mixture. And what is freezing mixture? It's a mixture of salt and water. Now what do you see? Observation. Follow the book again. Number 1. Initially both the thermometers T1 and T2 show same temperature, that is room temperature. Okay, that is around 18 to 21 degrees Celsius. Alright. Number 2. First the temperature recorded by the lower thermometer T2 starts decreasing and finally it becomes steady at 4 degrees Celsius. Okay. While the temperature recorded in the upper thermometer T1 remains almost unchanged during this time. So now what do you see is that the temperature in the lower thermometer starts to decrease. Room temperature bada ghardai jन्छ re, and it becomes steady, means rokincha at what? 4 degree Celsius. Whereas there is no change in temperature at thermometer T1, means the upper thermometer. All right. Number 3. While the thermometer temperature recorded by lower temperature T2 remains constant at 4 degrees Celsius, the upper thermometer T2 shows a continuous fall in temperature up to 0 degrees Celsius, and then it also becomes steady. So now at the third stage, what you see is that temperature at the lower thermometer, that is T2, remains constant, but the temperature recorded by the thermometer T1 starts to decrease, that is fall, and reaches to 0 degrees Celsius, and then again it becomes steady, that is, it remains fixed there. Thus, finally the temperature recorded by upper thermometer T1 is 0 degrees Celsius, and that by the lower thermometer T2 is 4 degrees Celsius. Okay, so the figure number 6.4 shows the variation in temperature recorded by thermometer T1 and T2. So here you can see on the video that this is the apparatus for demonstration, okay, of the anomalous expansion of water. You have thermometer, upper thermometer T1, and here you have the lower thermometer T2, and this is the trough. It contains a mixture, freezing mixture. And now what is freezing mixture? Freezing mixture means it's a mixture of, okay, mixture of salt and ice. Clear? Now what is the use of this freezing mixture? Because it reduces the temperature or lowers the temperature below 0 degree Celsius. Now you know temperature of ice is usually 0 degrees Celsius because ice is formed at 0 degrees Celsius, isn't it? So this freezing mixture brings down the temperature below 0 degree Celsius. All right, now let's see the explanation. What do you see? So here this is the paragraph which explains it. Initially water in the cylinder is at room temperature, say 12 degrees Celsius, when it's indicated by the point A in the graph, okay, as the freezing mixture cools water in the central portion. So at the central portion the freezing mixture is cooling down the water. Understand? So water contracts on cooling, isn't it? On yes, cooling, isn't it? Yes, and its density increases. Consequently the cooled water, what happens? It sinks down, गरम हुन्छ, डुब्छ, मुनि जान्छ to the bottom, and the warm water from the bottom rises up to takes its place. Thus by convection water of the lower part cools, so the reading of the lower thermometer T2 falls rapidly. The reading of upper thermometer T2 does not change because the temperature of water in the upper part does not change initially. Alright, this continues till the temperature of the entire water, okay, reaches 4 degrees Celsius. Thus, okay, this is shown by the part AB in the graph. Now, the reading of the lower temperature thermometer T2 becomes steady. On further cooling below 4 degrees Celsius due to anomalous expansion, water of the central portion now expands, so its density decreases and hence it rises up. So, its density decreases and hence it rises up to take its place. So, water from top descends down by convection. Water above the central portion cools. So the reading of the upper thermometer T1 now falls rapidly till 0 degree, okay, Celsius. Clear? This is shown by part BC in the graph. So part BC, here we have the part BC on the graph. At this stage the lower thermometer T2 shows the temperature 4 degrees Celsius at which water has maximum density. So here this temperature recorded by the lower thermometer is 4 degrees Celsius, which shows that water has maximum density, okay, at 4 degrees Celsius. All right, clear? Okay, the next topic is now consequences of anomalous expansion of water, means result. What do you see? What are the results? What are the expectations that we can have by the anomalous expansion of water? Number one is the anomalous expansion of water helps, okay, in preserving aquatic life during the very cold weather. Now for this, let me explain you all with one diagram. Suppose I have a pond here, and in the pond what do I have? I have water okay, and some marine life or aquatic life, that is there are plants, okay, and there are fishes here, okay, there are fishes here in this pond. Now in the very very cold winter days and nights, you will see that the temperature will fall. Now if the entire pond freezes, what will happen? Along with the water which has freezed, water will also freeze and they will suffocate and die. So all the aquatic animals will die in the winter season. But that does not happen. Yes. Why? Because what happens is that now as the temperature falls down, the upper layer of the water, okay, loses the temperature. Okay. Now if the temperature of the water initially was at 10 degrees Celsius, what will happen? The water temperature of the water will fall, and when it reaches to 4 degrees Celsius, what will happen? At 4 degrees Celsius, water has the maximum density, you know that. So water will start to go down, understand? Yes, and the warm water will go up. So cold water will fall down, whereas the hot water will rise up. So there is a convection current, okay, maintained here. Okay, so this process will continue where until the entire water in the pond has a temperature of 4 degrees Celsius. So now at this place, what will happen is that when the water now further starts to cool down, what will happen? It will expand. Now you know that water on cooling from 4 degrees Celsius to 0 degrees Celsius, what will happen? It will expand. Now when the water expands, you all know that its density will decrease, so it will not sink down but will start to float here. So as now the temperature lowers and lowers and lowers, what will happen? The upper layer of the water will start to freeze and it will form ice crust here. Now you know ice is a poor conductor of electricity, so now it acts as insulator here. So now what happens? A thick layer of ice is formed only on the upper surface of the lake, whereas at the lower surface of the lake it is still water here. So it is still water here, and the temperature of the water here is 4 degrees Celsius, and this temperature is very very ideal for the fishes and the aquatic plants and animals to survive. So that is why even in the very very harsh winter season, the entire pond does not freeze, but only the upper layer of the pond freezes, okay, and preserving the lower water temperature of the lower water at the lower portion at 4 degrees Celsius, and thus helping in the aquatic life to survive. All right. Now the second one that you have on your book is this one. Anomalous expansion of water is responsible for the burst of water pipes and lines and destruction of crops during the very cold night. So this is the other consequence. Okay, so in winter nights, as the atmospheric temperature starts falling below 4 degrees Celsius, water in pipeline expands. Now you know that when the water is further cooled down from 4 degrees Celsius to 0 degrees Celsius, what happens? It's expand maneko fully nuthalcha, isn't it? So when it expands, it exerts large pressure on the pipes, causing them to burst. So this is the reason why, okay, during very very chilly winter, the water pipeline starts to burst. Okay, so plants also die for the same reason, as their capillaries burst when the water expands below 4 degrees Celsius. So to protect plants, the field is filled with water. So how do you protect the plants in winter season? By filling the crop field with water. Understand? So these are the two consequences that has been explained in the book. One is the anomalous expansion of water, which is helping the aquatic life to survive in the very very cold winters, okay, or cold weather. And number two is the anomalous expansion of water leads or is the responsible for the burst of pipelines and for the damage of crops in the winter season. All right, so I hope you have understood all these things. If you have any doubts, if any queries has to be met, any topic has to be discussed again or explained again, please do let me know in the class group. All right, so that's all for today. Thank you.